Hey everybody, thanks for joining me for section 2 extension section today, which is on slope of parallel and perpendicular lines. The extension section today is just a little bit of a step up from what we had talked about last time with slopes of lines. In this case, we'll be talking about two specific examples of parallel lines and perpendicular lines. So let's dive right in here. It'll be a rather short lesson today on the extension section. For our key idea, it says parallel lines and slopes are lines in the same plane, so the same coordinate plane, that do not intersect. So they never intersect and are parallel. So non-vertical parallel lines have the same slope, and all vertical lines are parallel. Right? So all that's saying is this blue line here and this red line here will never intersect. You see how the arrows on the ends mean they keep going for forever. They will never intersect because they're parallel. They'll always stay the same distance apart from each other. And actually, you haven't quite learned this yet, but the number that's in front of the x here in this equation is our slope. And you'll see that it's 1/2 for both numbers. So like right here, oops, I accidentally clicked save, but you have 1/2 in front of x, and what that means is that the slope of each one of those lines is 1/2. So when you have parallel lines, their slopes are the same, and they will never ever intersect. So let's look at the first example here and see how we can tell which of these lines are parallel. And then basically we need to say, how do we know? Well, giving it just a quick glance, they almost look like they all could be parallel lines, but to be sure, let's check their slopes. Okay. So for my blue line, I'm just going to go from one point to the next. Remember, slope is rise over run. So how many up do I go and how many over? 1, 2, 3, 4. So up 4 is my rise, to the right 1. So my slope for the blue line is 4. The red line, again, rise over run. I go up 1, 2, 3, 4, 5 over 1. So red has a slope of 5. So my red line is a bit steeper. And then green has a slope of 1, 2, 3, 4, up 4, to the right 1. So it says what two lines are parallel. That would be the blue and the green are parallel. And then how do you know? They have the same slope. Okay, that's what we're looking for when we're checking for parallel lines. So when you are practicing this in your homework, you'll have like 6 problems to do that are essentially the same as this. And then you'll just have to say whether they're parallel or what lines they're parallel with. Okay. In the next example, or the next key idea, we'll talk about perpendicular lines and how that differs. So perpendicular lines and slopes, it says lines in the same plane that intersect at right angles is the key here, are perpendicular lines. So they kind of make what I sometimes call an X, or like the perfect T, where they have this 90-degree angles that are being created. Two non-vertical lines are perpendicular when their product of their slopes is -1. The product of their slopes is -1. Okay, that's important to remember. I'll show you that in just a second. And it says vertical lines and perpendicular lines. Vertical lines are perpendicular to horizontal lines. So if we had a straight horizontal line and we had a straight vertical line, we would say that these are perpendicular. Okay. And actually, an example of that would be your x and your y axis are perpendicular. They create a 90-degree angle. All right, let's try an example 2 to say which of these two lines are perpendicular and how do I know? So I'm going to go about this again in the same way that I did the first example, and I'm going to find the slope of each line. So the slope of each line. For my green line, I'll start with, that has a slope of, 1, 2, 3, 4, 5, 6, 7, up 7, over 2. Rise is 7, run is 2. My blue, my rise is 1, 2. I'm going up 2, and I'm going left. Be careful when you're going left because that's negative. 1, 2, 3, 4, 5, 6. So going left would be negative, so negative 6. And then my red is up 1, 2. My rise is 2. I'm going up 2. My run is 1, 2, 3, 4, 5, 6, 7. So this would be negative 7. Just a reminder, if you on slope here quickly, you don't have to go. Maybe you went a different way when you counted your slope. Maybe you said, okay, I'm going to start at this point, and I'm going to go down 2. So that's negative 2. And I'm going to go right 7. So that's positive 7. Well, remember, that's the same thing. It's the same as negative 2 sevenths. Just like that. The negative can apply to either the numerator or the denominator. Not both, but one of the two, and it remains negative. So now I have to look and see what is that relationship of perpendicular lines? How can I find out which of these two are perpendicular? Well, remember, it said that perpendicular lines, their slopes, the product of their slopes is negative 1. So when you multiply them together, product, you should get negative 1. Well, the other thing that you can think about is, okay, let's take a look here. If I were to multiply the green and the blue, I'd have 7 halves times 2, 6, and this is negative. This is going to give me a negative answer. I could simplify first, right? Divide each of these by 2, and I'd have 7, 6. Now, that's close to 1, but it does not equal 1. And we're looking for negative 1 specifically. How about green and red? And what is the other correlation or relationship that these two have? Well, if you look, one is the reciprocal of the other, and it's the opposite sign. So the other way that you can think of perpendicular slopes is they have the opposite reciprocal sign. So one is positive, one's negative, and then remember the reciprocal is the fraction flipped. So the numerator becomes the denominator and the denominator becomes the numerator. Let's just double check to make sure. We had 7 halves times 2 sevenths, and this is negative. 7 times 2 is 14. 2 times 7 is 14. And positive times a negative is a negative. And that simple 14 divided by 14 is 1, and we'll keep our negative sign. So the two lines that are perpendicular are the green and the red are perpendicular. And it's tough to tell just by looking. So we need to be able to find their slopes and compare the relationship of their slopes. All right, similar to the last one, you have about 6 problems to practice with that example. And that does it for me today with slopes of parallel and perpendicular lines. I will see you guys next time.